Okay, as we said earlier, selection combining actually chooses the highest SNR amongst all the branches. So let's say that we have two gammas, two branches, so we have two SNRs, right? And this is the first one, and let's change the color and this is the second one, right? So here we choose the best one, right? So in the first instant we use gamma 2, then here we use gamma 1, then go back to gamma 2, then gamma 1, and so on, right? So in this case, as we said earlier, we need to monitor each branch, and maybe the difference between the two branches is not very high. So actually sometimes it's not really worth it to move from one branch to the other, meaning that the gain that we get when we change the branches is not really high. So to simplify matters here, we or what is proposed is the threshold combining. Threshold combining actually sequentially scans each branch to choose the best first one. So the first branch that is greater than some threshold, as we saw earlier, it might be the receiver sensitivity related SNR or the required SNR to achieve a certain bit rate, and so on, right? So it will choose the first one. So if this algorithm finds one branch, it doesn't look at the others, it stops. If the SNR drops below that thresholds, it continues to scan the rest of the branches, right? It all it's also called um, switch and stay combining. So it has two names: threshold combining and switch and stay combining. So it is an improvement on the selection combining. Here we find or we see a figure, right? So we have two branches as we see earlier, branch 1 and branch 2, and we have the threshold here. So we in the first let's say period here, right, we choose branch 1, let's say. So let's say this is the dotted one is branch 1 and the dashed one is branch 2. So we choose the branch 1, then we move to branch 2. The important thing that we are above gamma threshold, right? So when branch 2 drops below gamma threshold, we then go back to branch 1 and so on. So the algorithm or this combining method, it's a bit more involved, and so is the outage probability. It's not very difficult, right? But you can see we need to include gamma threshold in the expression of the outage probability, right? So we have actually two cases here, right? When the gamma threshold is less than gamma node, and which is the required um, SNR, and the other case is when gamma node is greater than the threshold SNR. So let's take an example, right? It's the same as the previous example now, but now we have a threshold SNR of 3 dB. We need to find the receiver um, outage probability. Okay, so as before, we have the same gamma here, right? It's 4.81. We found it from the bit error rate, remember, and in dBs it's 6.82. Now we can see that gamma node is greater than gamma threshold, which is 3 dBs here, so we choose or we use the first branch in equation 10, right? And now we need to use the linear values, right? So this is the linear value of gamma bar, and we plug it in the expression, and we find the outage probability, which is actually 6.54%.